Welcome back, business calculus students. You are on the home stretch of our midterm review. In this section of our videos, I'm going to be working problems 27 through 30 regarding the application of derivatives. So let's begin with problem number 27. Consider the function f of x equals x to the fourth minus 2x squared plus 1. Find the slope of the function at x equals 2. To find the slope of a function, we need to calculate the first derivative. When we find the first derivative, we will plug in x equals 2, and that will give us the slope of this function at 2. To find the derivative of this function, we will apply the power rule term by term. We obtain 4x cubed minus 4x. To figure out the slope at the specific point 2, we will simply plug 2 in for x and evaluate. So we have 4 times 2 cubed minus 4 times 2. To avoid those common calculation errors that we all make, feel free to punch this into your calculator and make sure you obtain the correct value. We end up with a value of 24. So the slope of our function at x equals 2 is 24. Did you know that your calculator can determine slope? Let me give you a couple of tips on how to check this with your calculator. If you will go to y equals on your graphing calculator and type in the original function, x to the fourth minus 2x squared plus 1, and then graph it in the standard viewing window, you'll see kind of a W shape. We're interested in calculating the slope of the curve at x equals 2. So we're looking at this point right here, and we're going to calculate the slope of a line tangent to the curve at that point. To calculate slope, we're going to use this Calc menu directly above your Trace button. So to access that menu, we do our second key and the Calc button. Notice option number 6 is dy over dx. That's the same thing as derivative. And we're interested in calculating the slope at x equals 2. So type in 2 and press enter. Notice the calculator approximately evaluates the slope at about 24. The calculator will have some rounding error, but it verifies what we did analytically by hand, that the slope is 24. Part B says write the equation of the line tangent to f of x at x equals 2. To do so, we need to use the point slope form for the equation of a line. That is y minus y1 equals m times x minus x1. Make sure you memorize that for your midterm exam. M is the slope of the curve. That's what we calculated in part A. X1 is the x value of the given point. Y1 is the y value of the given point. At this moment, we don't have that information, so we'll need to calculate that first. To find the y value that corresponds to x equals 2, we're going to find f of 2. Notice I'm using the original function to calculate the y value. We'll evaluate 2 to the fourth minus 2 times 2 squared plus 1. This is 16 minus 8 plus 1. 16 minus 8 is 8, and 8 plus 1 is 9. So 9 is y1. Let's plug this information into our point slope form. Remember, x and y in point slope form are the actual variables. x1, y1, and m will represent constants. So we obtain y minus y1. y1 was 9. M, remember, is the slope of our function. We calculated that in part A. And x1 was the given value of 2. Now, it's customary to express this in slope-intercept form. If you'll remember, that's the form y equals mx plus b. So we simply need to isolate y. Before we do that, let's use our distributive property and break up parentheses on the right side. So we have y minus 9 equals 24x minus 48. Then we will add 9 to both sides to obtain 24x minus 39. Negative 48 plus 9 is 39. So we end up with y equals 24x minus 39. You can check this on your calculator by graphing it on the same screen where we have our function. If you'll go down to y2 and type in the equation of our line, 24x minus 39, and take a peek at the graph, we're just going to inspect it and make sure it at least looks tangent. This is absolutely no substitute for calculating it by hand, but at least it will give us an idea that we're not too terribly off. Oh, left off the x here. Let me add that in and inspect the graph. There's our function f of x and anticipating the graph of the tangent line. There it is. So at x equals 2, y equals 9. That was a little higher than I originally inspected. We have a line that's tangent to the curve. So feel free to use your calculator as a support on your analytic work. All right, you have arrived at the last page of your midterm review. Problem number 28 says, often sales of a new product grow rapidly at first and then level off with time. This is the case with the sales represented by the function s of t equals 400 minus 200t to the negative 1, where t represents time in years. Find the rate of change of sales for the following number of years. Working these word problems is simply a matter of interpretation. When it asks for the rate of change, it's simply asking for a derivative. We need to find s prime of t. That will give us the rate of change of sales with respect to time in years. Differentiating term by term, notice the first term in the function is a constant, so its derivative is 0. For the second term, we can apply the power rule, first filtering through our constant multiplier and applying the power rule to t to the negative 1. Our derivative becomes positive 200 t to the negative 2. If you wish, you can express that as a fraction. As long as you understand this exponent only applies to the t, not the 200. So as a fraction, this is 200 over t squared. So we've calculated our derivative function. We will use that to find the answer on part A and part B. On part A, we need the rate of change at 3 years. So that means I'm going to plug t equals 3 into the derivative. We obtain 200 over 3 squared. So the exact answer to this problem would be 200 over 9, but we can approximate that and get a dollar value with our calculator. So on our calculator, I'm just going to do second quit to go back to the home screen. We will type in 200 divided by 9. We will round this to 2 decimal places. When you're working with money, you always go 2 decimal places. So this becomes 22, $22.22 per year. Remember, t was time in years. So I'm measuring dollars per year when I calculate the derivative. On part B, I'm going to be using the same derivative function, but I'm changing the t value. So when we plug in 7 for t, we end up with 200 over 7 squared. Exactly, this is 200 over 49, but again, we can approximate that with our calculator to get the dollar value. So 200 divided by 7 squared, or 49, and rounding to 2 decimal places gives us $4.08 approximately. So $4.08 per year. So it's very simple. Find the derivative and plug in the given values to evaluate the rate of change. Problem number 29 says, suppose the demand for a certain item is given by D of P equals negative 3P squared minus 5P plus 200, where P represents the price of the item in dollars. So P is price, D is demand in number of units of that certain item. Part A says, find the rate of change of demand with respect to price. Remember, when it asks for rate of change, that indicates a derivative. Recall, this is an instantaneous rate of change as opposed to an average rate of change. So D prime of P becomes negative 6P minus 5, just differentiating term by term using the power rule. So our rate of change function, d prime of p, very simply, is negative 6p minus 5. So far, so good? Part B says, find the rate of change of demand when price is 15. Now, we've already calculated the rate of change function. That was d prime of p in Part A. Now we need d prime of 15. So we simply plug 15 in for p and evaluate. Negative 6 times 15 minus 5. Feel free to use your calculator again so you don't make those silly little calculation errors that we often do on a test. We end up with negative 95. So d prime of 15 is negative 95. Let's make sure we understand what that means. This means demand, the rate of change of demand, since it is negative, we say demand is decreasing 95 units. Remember, demand measures the amount of units per dollar of price increase. Okay? We have finally arrived at the last problem on our midterm review worksheet. You thought we would never get there. Let's cross the finish line here. The total cost in hundreds of dollars to produce X units of a product is C of X equals 4X minus 1 over 2X plus 5. Find the average cost for each of the following production levels. So this one is asking for average cost. Make sure that you read very carefully. Some problems will deal with average cost, some will deal with marginal cost, and some will deal with marginal average cost. When you hear average cost, that simply means to take your function and divide by x. So average cost, denoted C bar of x, is total cost, C of x, divided by x. Average cost is total cost divided by x. Our total cost function is given in the problem. And to make this easier to manipulate with that rational function, I'm going to rewrite this as 1 over x times C of x. Okay, we're getting ready to plug that rational function in right here. So it's a little easier to see the 1 over x part represented right there. So our average cost function is 1 over x times the given total cost function. Gluing that denominator together, we obtain average cost is 4x minus 1 over x times 2x plus 5. Part B, we are finding the average cost at 20 units of production. So we're simply going to take our average cost function that we just determined and plug 20 in for x. So we obtain 4 times 20 minus 1 over 20 times 2 times 20 plus 5. Okay, I'm going to simplify this a little bit by hand so that it will be easier to type into the calculator. In the numerator, we have 4 times 20, which is 80, and 80 minus 1 is 79. In the denominator, we have 20 times 2 times 20 is 40, and 40 plus 5 is 45. So we have 79 divided by 20 times 45. I'm going to let my calculator do that part. 79 divided by, be careful here, I have to group my entire denominator in a set of parentheses in order to get that product to actually be in the denominator. So I type that into my calculator and we end up with 0.09. Now remember, the cost is given in hundreds of dollars. So if average cost of 20 comes out approximately 0.09, if we multiply that by 100 by moving the decimal to the right 2 places, we end up with $9 per unit. Okay. Last question, read carefully, says find the marginal average cost function. Marginal is the code word for derivative. Okay? So if the problem asks for average cost, we divide by x. If the problem asks for marginal cost, we would simply find the derivative of cost. But because this problem asks for marginal average cost, we need to differentiate our average cost function. So remember, our average cost function was determined on part A. It was 4x minus 1, and in the denominator we had a product. I'm going to go ahead and distribute that x into the denominator so that it will make our upcoming quotient rule a little easier to evaluate. So we have 2x squared plus 5x there in the denominator. Now, to find marginal average cost, we're going to find the derivative of this function. Notice it's a quotient, so we will be applying the quotient rule. So, as we've been doing throughout this whole review, let's begin our quotient rule by squaring the denominator. That reminds us to lead with that term in the numerator. And we follow the pattern same times derivative minus derivative same. So here we have the denominator times the derivative of the numerator minus the derivative of the denominator, which is 4x plus 5, times the original numerator, 4x minus 1. Okay, so all we lack is to simplify this expression. We're going to do that by first distributing the 4 in the numerator here. We would end up with 8x squared plus 20x. And on the second set, we need to FOIL and distribute a negative at the same time. Okay, so let's take it little by little. On our FOIL process, we multiply our first terms together. 4x times 4x gives me 16x squared. But remembering to distribute this negative, we're going to end up with negative 16x squared. Okay? Outside terms would be 4x times negative 1. That gives us a negative 4x. Inside terms, we have plus 20x. That gives me a plus 16x for my net middle term. However, remembering to distribute that negative, we end up with negative 16x. For my last, we have 5 times negative 1, which is negative 5. Distribute the negative there to get plus 5. So that last part, we have negative 16x squared minus 16x plus 5. We still have our denominator hanging out here. I'm not going to forget about it, so I'm going to go ahead and write it on that step. The last thing we need to do is combine like terms in the top, starting with our highest powered term. So 8x squared minus 16x squared gives me negative 8x squared. For our linear terms, 20x minus 16, we end up with plus 4x. And finally, we have our plus 5 constant in the top. And don't forget about the square of our denominator. That gives us our marginal average cost function. Remember, to find average cost, we divided total cost by x. To get the marginal, we simply found a derivative. Ask yourself, would I know what to do if it just asked for marginal cost? Certainly, you would just differentiate your original cost function. Well, that wraps up our midterm review. Feel free to go back through these videos as many times as you need to until you feel comfortable working these problems. If you feel good about the problems we've worked through, you are prepared for the exam. If you are unsure, go back, print out another review, and practice until you feel confident that you can work them. Remember, any formula that you need to work these problems, be sure to memorize that for the exam. You can't use a note card or any kind of a reference on the exam. Best of luck to you on the midterm exam. Y'all go make me proud. Thanks for listening.